सर एक्चुअली दिल्ली में इलेक्ट्रिसिटी बहुत जाती है सर, और शादी में बड़ी प्रॉब्लम होती है सर उसकी वजह से। तो मैंने सोचा कि एक ऐसा इन्वर्टर बनाऊं जो शादी में आई हुई गाड़ियों की बैटरी से पावर ले सर।
अच्छा,
वाह, तो बना दिया इन्वर्टर?
सर डिजाइन रेडी है।
Hi, I wanted to build an inverter circuit. So idea behind that inverter circuit was that there will be a standard lamp, a circuit and a simple power bank. So with that inverter circuit, not only one can light a lamp but also can charge a small device, means also can power a small device such as Wi-Fi and something which needs very less power. The transformer I used is 606 300 milliamps. If I used a higher 500 milliamps or more, then I could have drawn more power and supplied more power to my devices. I need an oscillator circuit. I am using 555 timer for periodic oscillation, and here I am using IRF Z44N channel MOSFET to drive my transformer, because MOSFET can handle higher current. I am just touching the gate and seeing, you can see the light is getting dimmed. So I'll be building the whole circuit with the periodic timer and the MOSFETs. So here is a small demonstration. It is in its frequency is 1 Hz approximately. I tried to simulate the whole circuit and as you can see, I am using 2.2 kilo ohms and 135 kilo ohms resistance and 100 nanofarad capacitor. The yellow bulb is actually my transformer, and I tried to put a original transformer, though it is not center tap, but my simulation actually didn't give me any result, so the output was faulty, and so I decided to do it practically and not more like theory. I really could not get any result from this simulation, means at the last stage. So this is the circuit, final circuit diagram which I am using. Then let's assemble the whole circuit. So one thing about the circuit is that it can power low power devices like a LED lamp, but it fails to power a high power devices like incandescent lamp or anything which needs more power, more current, more voltage. I tried to make this circuit and there were failures. One time the chip was wrong. This is a whole model, means how it looks, but this failed actually because the chip did not function, and then there was failures because of loose connection and also wrong connection. So here is an example of one of the failure. So here, after giving 5 volts, as you can see in the multimeter, I am not getting any result voltage. Failures do come and we need to overcome it. So again, starting from scratch, this is the 555 circuit diagram theory, and this is the resistance and the capacitance I am using. So after a successful circuit design, I am getting this result. This is actually from front camera. You can see the flickering of LED when anti-bending of camera is off at 50 Hz. So here directly the output of 555 timer circuit is connected to the transformer one end, and from the other end I am getting around 43 volt. This is a very good news, means like really very good news. So next, after hooking up with the MOSFET and doing the whole circuit, I am getting around 194 to 200 volts. To remember that my multimeter is not so much accurate. It has an accuracy of plus minus 10 volt for this AC, which I think. So this is the transformer. This is the circuit. Now safety is first priority, hence I have just covered it with the black tape, and then I'll assemble the whole device. So after assemble, the whole device looks like this internally. So when there is no load, the output from the transformer is 204. So it's 190 to 204 volt, and it draws around 15 milliamps from the power bank without any load. Milliamps from the power bank when there is a load, that is this 9 watt LED bulb. So this is the whole circuit. You can see whole setup design. and that's it. So it is very cheap, and by changing the transformer and tuning the circuit, we can actually power a laptop with it. So we need to actually fine tune the circuit, and we need to do more R&D, more optimization, which I'll do in the future. So this is the current 2 milliamps, 2.83 milliamps current is drawn by the LED bulb at a voltage of 90 to 110. Yes, on load the voltage I have measured, it is around 90 to 110 volts, and ampere is 2.8 milliamps. Word of caution, this is not a very efficient circuit. More efficient circuit can be designed. Normally it is a very robust circuit, you can change the bulb and you don't need any heatsink, but the circuit is not very efficient. So here I have used a 60 watt Philips incandescent bulb, and you can see it is not lighting up because the circuit cannot deliver so much power. But with the LED lamp, it can deliver this much power such that it lights up. And so this is a moment of joy for me. So you can light that lamp using laptop, phone with OTG connection, and also a tablet, because it draws so much less power. This is a normal 220 volt Philips 9 watt bulb at 220 volt in the household, and this is the result lux output of it. It is actually saturating my lux meter of the phone. So I use the phone lux meter, phone based lux meter. So this is the bulb, and so this is the specification of the Philips bulb which I am using. This is a 9 watt bulb. So in normal case I am getting around 2000 lux, but in my circuit I will be getting around 1000 to 800 to 1000 lux, like that, just the half of it or less than that. So you can understand that how poor the efficiency is, but it works and it is highly robust. So the whole room lights up using my power bank. So if you like the video, please subscribe, share, as it encourages us to make more videos like this. So in future we'll try to make a circuit which can power the laptop.